We, the students of PhD College of Technology from the Department of Robotics and Automation Engineering, are here to explain you about the mobile document scanner. This is the basic concept and idea behind apps such as Cam Scanner and other apps which are available on the App Store for commercial use. The content which is going to be covered in this video are introduction, how it is achieved, challenges faced, process, code, output, source, and working demo. Okay, so what is it all about? Document scanner is a process of scanning the image and converting to digital forms using programs like OpenCV and Python. Why do we need to use this, or what is the purpose of such scanners? Ultimately, to convert non-digital content to digital ones. To achieve a scanned document, we need to follow 6 basic steps. They are reading the image, identifying the edges, detecting document edges in the image, identifying and extracting document boundaries, applying perspective transform, and the final magical step, which will be explained during the code. However, the use of smartphone introduces new challenges to document scanning which are not faced by classical document scanning devices. These include uneven lighting, perspective distortion, non-planar surfaces, motion blur, and low resolution of the camera. So here is the concept. In the first step, if the image dimensions are higher side, you might prefer to scale it down for faster processing and resize it in the current window. So we need to load the required image to the software. In the second step, to reduce any color noise, we convert color images to gray images. So why do we convert color images to grayscale? It is because a colored image has a depth of 3, one for each RGB color, whereas gray images have depth of 1. Then we apply blur function to blur the image to remove any high frequency noise on the image. So in the step 3, the edges are detected in the entire image. It is done using canning edge technique. And why canning edge technique? Canning edge technique uses a multi-stage algorithm to detect a wide range of edges in an image. The size of the document is calculated, and that is going to help in detecting the contours. To obtain a top-down bird's-eye view of the document, we will transform the extracted region of interest into required perspective. Here, we will prepare image for final display. This step might be optional, and it totally depends on the user how he or she wishes to see the document, such as vision, contrast, increasing brightness are applied to enhance the image. The use of these devices for document scanning provides interesting advantages over the traditional document scanning devices. They can be used to scan thick books, historical documents that are too fragile to touch, text in scenes such as walls, whiteboards, etc., and large-sized documents. So the first step is a very basic one where we import the required libraries for the program and define the path of the input image which has to be scanned and processed. Then the image is read using cv2.imp function and stored in image, and also a copy of it in org. Once it is stored, we then display the image to make sure the image has recognized the path using the function cv2.imshow. So coming to the second step, here we convert the colored image into grayscale using the function cv2.cvtcolor, and it is stored in gray image. So once the image is converted into grayscale image, an image blur is applied to remove the high frequency noise. It is achieved using the function cv2.blur, and a filter of 3,3 is used. And the edges are detected by cv2.canny function, which is nothing, basically the canny edge technique which is being used here. And then all the 3 images, gray blur and edge detected images are being shown. The third step, we find the contours in the edged image. So we need to find so how do we find the contour images? It is pretty simple. First we need to find the area, and the area is calculated using the function cv2.find contours and cv2.contour area, and the area which has the largest the largest area is the document. So that is then saved in, and it has been displayed here, cv2.imshow. So now the fourth step is the most complex part. The four coordinates of the document is taken as top left, top right, and bottom left, and they are computed like a rectangle. So the top left is supposed to have the smallest sum, the bottom right will have the largest sum, the top right will have the smallest difference, and the bottom left will have the largest difference. So that is then calculated, and they see which width A or width B is the largest, and height A and height B is the largest, and they use the function max of height A and height B, then it's stored in height. The same thing used for the width as well. So now once this has been calculated, once a contour has been obtained, we then apply the bird's eye concept, in the fifth step, which is applied using cv2.getPerspective transform, and it is stored in scan cv2.parPerspective, and then it is being displayed. So once the bird's eye view or the perspective view is achieved, it is again converted into grayscale, and so this is the final step, the sixth step. So in the sixth step, according to the user, they can either increase the brightness or the contrast, or they can rotate the image however they want, but in our case we have increased the contrast to get a better vibrant look of the output. So this is the output. So once we load, the first step is we change it into a gray image, then a blur is applied. With the help of the blur, using canny edge technique, edges are being detected, the contoured edges, and the gray image which has the bird's eye view, first perspective view, and it is then scanned, and the contrast has been increased. So we have doing input versus output. So this is the first image which we imported, which was photographed using a phone, and this is the process output using OpenCV and Python. So our sources are displayed here. We hope you have understood the concept of how a document is being scanned in apps like CamScanner, and we will show you the working video. Thank you for watching.